Okay, algebra students, this video will provide the solutions for Builder 2. There are a number of learning standards covered in this video, and the first is 4C, which is a supporting standard on the STAAR test. You can expect to see a question like this. Let's read the question and then solve it. Chef Steven is planning to order beef needed to make hamburgers for his food truck restaurant. He contacted 6 beef suppliers and received the following estimates. Now here right away there is a little bit of a trick that they're doing. They've numbered the rows. Okay, they've numbered these 1, 2, 3, 4, 5, 6, but then in English they have written out 1, 2, 3, 4, 5, 10. So as we proceed, we need to ignore these actual numbers here and just look at the English words for the numbers. That's what they're trying to get you to focus on. 1 pound costs $3.75, 2 costs $3, 3 pounds $2.50, 4 pounds $2, 5 pounds $1.75, and 10 pounds is 50 cents. All of these prices here are per pound. Okay, so as we proceed here, make sure you keep in mind that this number here, $3.75, that's for 1 pound, per pound. And for 10 pounds, each one of those pounds costs 50 cents for this line here. What the problem requires you to do, well, I suppose we should read it. What is the best estimate of the total cost of 7 pounds of beef? Note, use 3 significant digits for all calculated intermediate values. We'll talk about that when we come to it. What you need to do to solve this problem is make a table. We're going to be putting this into stat edit, stat calc. So we need to make an L1 and an L2 table, where L1 is X and L2 is Y, or in this case, L1 is going to represent these numbers right here written out in English, and L2 is the cost per pound. So we could say that the cost per pound is a function of the number of pounds. And as you see, as the number of pounds increases, the cost per pound decreases. So there's an inverse relationship between the number of pounds and the cost per pound. Okay, so we'll write this out. 1, 2, 3, 4, 5, and 10. And then the corresponding values, 3.75, 3.00, 2.50, 2.00, 1.75, and 0.50. Okay, and this is the data that we're going to put into our stat edit on the calculator. So what you're going to be doing is putting this data in. So the stat edit table looks like this. You pause the video here and catch up with writing this down. You need to show this on your paper so that I know that you know what to do. All right, let's now transition to our calculator emulator. Make sure you clear the memory. Second plus 7, 1, 2. All right, and I'll clear my key press history, so if you're following along here on the bottom row or the bottom frame of this window, you can see what buttons I'm pressing. First, we click over here, click Stat. Okay, and then it's already highlighted on 1, hit Enter. Now, just like we showed, you're going to enter those values as they appeared in your table that you created. 1, 2, 3, 4, 5, and 10. The most common mix-up is students type 6 right here. Make sure you put 10, and then go over to L2, and then you'll put in the price per pound, 3.75, 3, 2.5, 2, 1.75, and 0.5. All right, so now what we'll do is go over here to this button and click Stat, and then move over to Calc. So right arrow to Calc, down to number 4. I'll click 4, or you could go down. Okay, so either way, I'll click 4 for linreg ax plus b. This is going to give us the slope-intercept equation of the line, where a stands in for m, and then we've selected the x list as L1, the y list is L2. These are the defaults. Make sure that's what they say. Always give that a quick glance, and then hit enter, 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 enter. And what you're given is this mess right here, and we're going to talk about that. So I am, you can't see what I'm doing right now, but I'm writing down A equals negative, and then I'm going to stop because we have to talk about significant figures. The problem told us to round everything to 3 significant digits. So in this case, 3, 3, and 9. And what you do is you kind of cover up the 3, 3, 9, and you look at this next digit right here. If this is a 5, 6, 7, 8, or 9, you're going to round the preceding digit up. But since this is a 3, we don't have to round. So what we're going to put down for A is A equals negative 0.339. And that's taken to 3 significant digits. Negative 0.339. Now that's the slope coefficient. So that's our M. Now let's look at B, or the Y-intercept. Here the 3 significant digits are 3, 6, and 6. Just like in what we did up here, you cover up this terminal digit 6 and you look at the next one. And again, this is a 3, so we don't have to round that 6. So we'll just write B equals 3.66. So this is, I'm about to show you my paper. You need to have written this down on your paper as part of showing your work. Okay, so here's my paper, and like I said, I've just written down, I've copied down that information. So if we want to write a linear equation for this data, we can. We can say y equals negative 0.339x plus 3.66. And that linear equation will contain all of these points. So we are now going to graph this just to take a look at it on the calculator. This is where I'm a huge fan of the calculator because I have no idea how to graph that odd slope right there perfectly. And also 3.66, hard to do on a piece of paper. So the graphing calculator will really help us here. And then we're going to look at the Y tables and see what the cost of 7 pounds of beef is. So 7 is an X value, so we'll look for 7 in the X table, and then we'll look to the right of that and see what the price per pound is for 7 pounds. But first, let's graph it. So we'll flash back to our graphing calculator and go to Y equals. So in Y equals, what we'll type in is negative. Make sure you click this negative symbol and not the minus sign. So we're going to click negative 0.339, and then we will hit this for the x variable, plus 3.66. Make sure that your equation looks just like this. Y equals negative 0.339x. Very often this x is missed, plus 3.66. And now, just for fun, we're going to hit graph, and we'll see that that's a downward sloping line. The y-axis represents the cost per pound, and the x-axis represents the number of pounds purchased. So it shows that as the number of pounds increases, the price per pound decreases. Okay, and that's that negative inverse proportional or negative linear relationship between the dependent variable, which is the cost per pound, and the independent variable, which is the number of pounds purchased. Okay, fair enough. Now, to move on with the problem, we're going to hit the second key and then graph. And that's going to bring up our tables. What we're looking for here is the y value that corresponds to an x value of 7, because it said how much is 7 pounds of beef. So here this is pounds, here pounds of beef, and the the y value that's associated with the 7 pounds of beef is 1.287. Okay, now as we did before, we have to round all intermediate values to 3 significant digits. So we're going to cover up that 8 and look at the next value. And so the next value is a 7, that's 5 or bigger. So we have to round the 8 to a 9. So what we're going to write down is, for 7 pounds of beef, the price per pound is $1.29. So we'll just write that down, $1.29 times 7 pounds. Let me go back to the work surface here. And before I go, I just want to mention, the information we were given, it said that 1 pound of beef costs $3.75 per pound. And the look up here at this value, this is $3.321. It's different. And the reason it's different is because we rounded to just 3 significant digits. So within the context of this problem, we're doing this correctly, but in a perfect circumstance, we would have been able to include all of the digits that we were given, but we're just rounding here. So given the parameters of this problem, this is still correct, 1.29. And we'll go back to our work surface. Now I'm over here now, and I've written $1.29 times 7 pounds. This is crucial. Notice that the answer B says $1.29. Now many students see that and they think that's it. But remember, $1.29 is just per pound. And it says here, what is the best estimate of the total cost of 7 pounds of beef? All right, so we actually need to multiply the cost per pound times the number of pounds. And it doesn't matter if you were to multiply, if you were to have written the 7 first and then the $1.29, it doesn't matter as long as you're multiplying 1.29 times 7. And 1.29 times 7 equals 9 $9.03. That's $9.03 total for 7 pounds of beef. And that's why the answer to number 1 is C. Okay, moving on to number 2. The following data were gathered from the graphs of lines J and M. J of X is defined for all values of X such that X is -9, -3, and 2, and J of X for all values of J of X such that J of X is 0, 18, and 33. M of X is defined for all values of X such that X is -4, 0, and 10, and M of X such that M of X is 10, 8, and 3. Write a system of equations in standard form to represent the data provided. Okay, what we're being asked to do is take this data, okay, take this data here and convert it into an L1 and L2 table and find an equation for the function J of X. And we're going to do the same thing for M of X. Then they'll both be in slope-intercept form, and we will manipulate each equation until it goes into standard form. And then we should find that standard form answer here. So let's start with J of X. We're going to make 2 different sets of tables here. So pay close attention. This is for J of X. L1 is the X value and L2 is the Y value. Okay, make a little table. It's always good to have a straight edge on hand. And then it says the X values are -9, -3, and 2. And order is important here, so be careful. And then for J of X, you have 0, 18, and 33. Okay, so now we will do the same thing for M of X, just so we know what we're going to be doing. And we have L1X and L2Y. Again, we'll make a little table here. And then for M of X, the X values are -4, 0, and 10. And then M of X, or the Y values essentially, are 10, 8, and 3. Okay, so this needs to go into your stat edit. We're going to do this one first. Okay, so we're going to just leave that alone for now. Let's leave M of X alone for now and just focus here on J of X. So we will flash back to our calculator now. And I will show you how to clear the stat table. Okay, so click stat and then enter. Maybe you can click clear list. I've never really tried this before. It didn't work. Okay, forget it. Go to stat and then click on edit. Go up and then cursor left to L1 and hit clear and then hit enter. All right. Then go up, cursor right to L2 until you're hovering over the L2 and hit clear, then hit enter. Do not hit delete because you'll delete the column. We just want to clear the column and hit enter. Now, if this didn't work for you, like, remember I went here and clicked clear list and it gave some error, okay? Error. If this isn't working for you and you still have data in these columns and you don't know what to do, just reset the machine. Second plus 7, 1, 2. Okay, remember that key sequence, or just turn your calculator over and push the back of it and clear the RAM. And then when you go to stat edit, they'll be cleared up. All right. So what I'll do now is just get us back Let me clear the key history. Remember, we're going to now click Stat, Edit. And then for L1, remember we're doing the J of X values. I have -9 for X, -3 for X, and 2 for X. In the Y column, L2, I have 0, 18, and 33. Now, we're going to find the linreg for this. Stat calc for linreg AX plus B. Enter, 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 enter. And it gives us, and I'm writing this on the paper and I'll show, y equals, I'm going to replace the a with the 3x, and then replace the b with positive 27, 3x plus 27. Okay, let me flash back to our work surface here. I've noted that here, y equals 3x plus 27. That is the equation of the line for j of x. You could have, and perhaps it would have been more correct to write j of x equals this, so y or j of x, just so we're defining it correctly for the function. J of x equals 3x plus 27. Either way, it's gonna function the same way. And now we'll do the same thing for m of x. So here, now we're focused on this data here. Let's go back to our graphing calculator and click on Stat, Edit, and we could clear the list or we could just replace the values. So we can actually just put -4, enter, 0, enter, and 10, enter. These are the x values for m. And then go over and replace these numbers with 10, 8, and 3. Okay, that replicates the m of x L1, L2 table that we wrote out. And now click on Stat, okay, right arrow over to Calc, and then option 4, linreg AX plus B, enter, 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 calculate. What you're given is y equals -0.5x plus 8. Now, so I'll write m of x slash y equals -0.5x plus 8. All right, let me go back to our work surface so we can talk a little bit about this. Here I've written that up here, m of x or y equals -0.5x plus 8. It's going to be beneficial to us as we work with these problems to convert them from slope-intercept to standard form if we write this decimal as a fraction, -0.5 as a fraction. Now, this one is pretty simple, but if you didn't know what to do, you could go back to your calculator. I'll show this really quickly, and click second quit, get back here, and type in -0.5, okay, and then enter. So now that's in the memory, and then click Math Frac, okay, enter, and it will convert your decimal into a fraction. Let me show that again. Negative symbol, 0.5, enter. Okay, and then you want to convert this decimal into a fraction, so click Math, and then the first answer, frac. And it's saying I'm going to convert the answer, which is this value, into a fraction. There it is. Okay, so that was just a small skill we need to do. we'll rewrite this using a little arrow as -1/2 x plus 8. And that's just going to aid us in the moving around of the values when we want to convert this into standard form. So let's convert our j of x, or y equals for j of x, into standard form. And because all of the answers are talking about x's and y's, we'll use the y equals notation instead of the function notation. So we'll write, maybe I'll write for j of x, just so I know what I'm doing over here. I'll write y equals 3x plus 27. Okay, that's slope-intercept form. Now remember, what I want is standard form. Now the standard form is ax plus by equals c, where a, b, and c are whole numbers and a is positive. Okay? This skill, again, I've said this in previous videos, the skill of converting from slope-intercept to standard and standard back to slope-intercept, this is kind of one of the three skills in Algebra 1 that it just is so important that you know how to do this. So I hope that I've stressed this so many times in class and in these videos that if you are a conscientious student who is taking their education seriously, you have now caught on that this is critical. This is important. And if this is not super fast with you, this is the skill that you need to practice over and over and over again until it is just effortless. So automatic, like you're practicing a piano over and over again until your fingers just automatically know where to go without you thinking. You need to be thinking like that when it comes to converting these equations. And that only comes with practice. It's not some miracle. No one is good at doing this when they're born. You have to practice it. So we'll now do that here. We want this to resemble the form ax plus by equals c. So I want to get this x value over here on the left side of the equation. So I'll subtract 3x from both sides. On the right side it cancels, and now I'll rewrite. I've got negative 3x plus y equals 27. Am I done? Well, let's check. I've got a, b, and c are whole numbers, and a is negative. So we're not quite done yet. We need to put parentheses around the entire equation and multiply everything by -1. Now the reason we multiply everything by -1 is because when I distribute that -1 through the equation, it's going to get rid of that initial negative sign. So -1 times -3 gives positive 3x. -1 times y gives negative y equals -1 times 27 gives negative 27. So now I've got this in standard form. A, B, and C are whole numbers, 3, -1, -27, and A is positive. Okay, so that was for J of X. Now we need to do the same thing for M of X. Okay, I'll even demarcate a little just so we know that it's a different setup here. We're going to write this down. Y equals -1/2 x plus 8. All right, so again, my goal is to get the x factors over here on the left side of the equal sign. So I will, because this is negative 1/2 x, I'll add 1/2 x to both sides. On the right side, the negative 1/2 x's and the 1/2 x cancel each other out. And on the left side, I'll just rewrite 1/2 x plus y equals 8. Is this in standard form? No, because the first coefficient, 1/2, is a fraction, and we need the coefficient to be a positive whole number. So what can we multiply the entire equation by in order to make this 1/2 disappear? Well, the answer is 2, because if I take 2 over 1 times 1 over 2, what I get is 2 over 2, which equals 1. So that's my goal. I want to turn that 1/2 into just 1, or x by itself. So I'm going to multiply, kind of run out of space here. Let me write this backwards. So I'm going to multiply this whole thing times 2. Every term will be multiplied by 2. So 2 times 1/2 gives me 2 over 2, which is just 1. Anything divided by itself is 1. And now I've got x by itself, plus 2 times 1y gives me 2y, equals 2 times 8 gives me 16. So x plus 2y equals 16. Is that in standard form? Well, I've got 1x, positive whole number, 2y, positive whole number, and then 16, whole number. Yep, it's in standard form. So now we can write our system of equations. 3x minus y equals negative 27, and x plus 2y equals 16. We're going to go find this answer choice here. 3x minus y equals negative 27. X plus 2y equals 16. Answer choice C. This problem contains a lot of elements of algebra in it. You've got to make a table, go to your calculator, get yourself an equation, and then you've got to put that equation in slope-intercept form for two different functions, solve each in standard form, then stack them up as a system. You know, the next step would be to solve the system, and we'll do that later using the matrix function on the calculator, but this is where you need to be on this problem number 2. Okay, moving on. Number 3, the graph of the quadratic function r is shown below. If k of x equals negative x squared and r of x equals k of x plus n, what is the value of n? Okay, this sounds harder than it is. The shortcut on this is to just identify some points. All right, just look at your answer choices. They're all whole numbers. So if you don't even know what you're doing, you can look around for numbers that appear in the graph. What is this guy right here? That's negative 3. Okay, that's an option. Over here I got positive 3. That's an option. These dots don't mean anything. They put them there to confuse you. So what else can you know? Well, the vertex or maximum and the y-intercept, all three of those things, here is y equals 1, 2, 3, 4, 5, and I've got y equals 5. And negative 4 doesn't appear anywhere on this graph other than to say that both of these dots reside on y equals -4, but that doesn't mean anything either. So just based on analysis alone, we might be able to see that 5 is the correct answer by looking at the y-intercept. But let's go ahead and work the problem correctly instead of playing games with the answer choices. Let's take a look. So k of x equals -x squared. Real quick, the parent function, y equals x squared, looks like this. Okay, that's x squared. -x squared just flips this guy upside down. So I'll use a red. If I wanted to do -x squared, it would be the same looking shape except flipped like that. This is -x squared. Now I'll use blue ink to show what we see here. Okay, this is just -x squared plus 5. -x squared plus 1, -x squared plus 2, -x squared plus 3, -x squared plus 4, -x squared plus 5 here. So if I wanted to draw that in with blue, I could draw it in right there. All it is the graph of -x squared shifted up by 5 points. Now, that's a terrible graph right there. It's confusing. So we'll use our calculator to kind of prove all this. So on your calculator, let's go ahead and clear the memory. 2nd plus 7, 1, 2. And then we're going to go to y equals. Go to y equals and type in -x hat, this button for exponent 2, -x squared. Okay, just graph that. Do you see how it's graphed like what we drew on the paper? Right, I'll show the full thing here. So if I delete that negative symbol and I graph it, it graphs like that. All right. So now if I go in and I insert that negative symbol back, now I graph it, it flipped it over. No big mystery there. Now let's leave that there and then go down arrow 1 to y2. And this time we're going to graph -x hat to -x squared. Right arrow. Make sure you hit the right arrow. If you don't hit the right arrow and you hit plus, you're going to put a plus symbol up there in the exponent. You don't want that. So hit the right arrow and then hit plus 5. Now watch this. All it did was shift the graph up 5 places. Okay, and if you look at the tables, you'll see that where y is equal to, or where y, look at y2, you have to look at the y2 column, where x is 0, y2 is 5. Okay, so that's showing that the y-intercept for -x squared plus 5, the y-intercept is 5. All right, so let's go back to our problem so we can interpret all of this. The question asked, if r of x equals k of x plus n, what is the value of n? All right, well, k of x, we already saw, k of x is -x squared, and then plus 5 gives us this graph right here, so n must be 5. See, this is 5. So this equals n. So because of all those reasons, the correct answer choice is B, 5. Okay, number 4. The growth of a bean sprout was measured each week over the course of 7 weeks. The dot plot below models the linear relationship between the height of the plant in inches above the soil line on the y-axis. All right, so this is the height. Start labeling your graph when you read. And the number of weeks on the x-axis. So this is weeks on the x-axis. All right. How many weeks prior to the start of the measurement period did the bean first sprout above the soil line? Okay, this is a confusing problem, potentially confusing. What it's asking us to do is to imagine that, and we'll use green because it's talking about a plant. Imagine that, because these are weeks. This is week 1, week 2, week 3, week 4, and this is the soil line, okay? Here's the height of the plant each week, so it's growing. Well, the question's asking us how long in the past, so to the left, into negative territory here on the x-axis, was the plant 0 inches tall. And in mathematical terms, it's really asking us what is the x-intercept of this linear function. Now, what it's asking us to do is put a straight edge on all those points. Okay, just graphically, we are going to go back in time and extend out these axes. And what we want to know is we want to know the x-coordinate of that point right there. That's the x-intercept. In other words, where this line, where this guy right here, intersects the x-axis. We can see that the y-intercept is at 3. But what is the x-intercept? Well, we have to figure out an equation for this line and then backtrack using our y tables to see where x is negative, where y is 0, because that will give us the x-intercept. The y-intercept is where x is 0. The x-intercept is where y is 0. So first we have to get an equation for the line. We only need 2 points to do this because it's obvious from the graph that this is a perfect linear relationship. Okay, I'm going to fill this in a little bit. Okay. This is a perfect linear relationship, and all I need are 2 points for perfect linear relationships to make the equation of a line. I like to use what are called lattice points, L-A-T-T-I-C-E. That's where the grid lines intersect because it's a little easier. So we'll do this point here. I need the coordinates for that point. Those coordinates are 2, 4. And here's another lattice point intersection right here. Okay, the coordinates for that point right there are 6, 6. If you wanted to do this the old school way, you could plug this into your slope formula first. So m equals y2 minus y1 over x2 minus x1 equals y2 is 6, y1 is 4 over x2 is 6, x1 is 2. Okay, to get the slope, which would be 2 over 4, okay, which can be reduced down to 1 over 2, 1/2. And then you could plug, that's m, 1/2. You could plug that into your point slope formula, which is y minus y1 equals m open paren x minus x1 close paren. We could substitute the values in y minus y1 which is 4, equals m, 1/2, open paren, x minus x1, which is 2, close paren, and then just solve this out. So you've got y minus 4 equals, distribute the 1/2 through the parentheses, 1/2 x minus, now look, 1/2 times -2, that's going to be, let's do that, 1/2 times -2 over 1. Okay, multiply the top, multiply the bottom. You got -2 over 2, which reduces down to -1. All right, so this is just distributing 1/2 to -2 gives you -1. Now add out the 4 on the left, add it to the right, and you have y equals 1/2 x plus 3, because -1 plus 4 is 3. So that's your equation. You need that. But let's say you just, this right here, let's say that your reaction to this right here was, you know, that's your reaction to this, question mark, unhappy face. We definitely going to have to learn this skill, right? But for the time being, we can actually just create an L1, which is the x values, and L2, which is the y values. I mean, I would prefer that you do it by hand, but what I really prefer is that you get the correct answer on the STAAR test. So for L1, we're going to put our x values. These are our x values, and that would be 2 and 6. And then these are our y values, 4 and 6. Okay, we'll jump to our emulator. We'll go to Stat, Edit, and put in 2 and 6 for the x values. And then we'll put in 4 and 6 for the y values. Then we'll click Stat, right arrow Calc, and then number 4 for linreg ax plus b. Enter, 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 enter. And there we are given a equals 0.5, y equals 3. We can write that out as y equals 0.5x plus 3. If you ever forget, you've got it written right here. Just plug them in, plug in the values. Okay, let's get back to our calculator. Oh, we need to do one thing. So 0.5, we need to write that as a fraction. So if you didn't know how to convert 0.5 into a fraction, you could hit 0.5 on your home screen, enter, and then hit math, frac, and it will tell you that 0.5 is 1/2. So the actual equation we want to write down is over here, y equals 1/2 x plus 3. That's the equation we need. What we're going to do now, since we've written this down, okay, that is the equation of this line right here. So what we're now going to do is, what do we say about the x-intercept? It's where y is 0. Okay, so we're looking for this value here. We don't know what that is, but we know that y is 0 for whatever that x value is. So what we'll do, and again, I'll show this both ways. So here's, if you're a little bit more advanced, you can solve this by hand. Y equals 1/2 x plus 3. All you're doing is solving for x instead of solving for y. So if you want to solve for x, We'll get x by itself on the left, subtract 1/2 x from both sides. Cancels that out. I've got negative 1/2 x plus y equals 3. Now this time I'm trying to get x by itself because I want the x-intercept. So what I can do is subtract y. This seems a little weird the first couple of times you do it, but it's exactly the same as when you're trying to get y by itself, but this time you're just trying to get x by itself. The y's cancel out on the left, and we'll rewrite negative 1/2 x equals negative y plus 3. And we will now multiply. So we need to get rid of this negative 1/2. So what we'll do is we will multiply through the entire equation by the reciprocal of the coefficient, not the negative reciprocal. Okay, the negative reciprocal of negative 1/2 would be a positive number. We just want the reciprocal, so we're going to multiply everything by negative 2 over 1. So I'm multiplying everything by negative 2 over 1. Here, this becomes 1, so these cancel. The 2's cancel, the 1's cancel, and you're just left with x equals. Now we're going to multiply everything over here by negative 2 over 1. Distribute, multiply that. So x equals negative 2y plus or minus 3 times negative 2, which is 6. Okay, so in this case, if I substitute in a 0 for the y, what will I get? Okay, so this is like inverse function. F inverse of 0 equals negative 2 times 0 minus 6. Well, negative 2 times 0 is 0. Okay, so that just cancels out, leaving me with minus 6. Right, and that's the x value we were looking for. So this equals negative 6. When y is 0, x is negative 6. So we know that's going to be negative 6, but again, we'll show it without the algebra. We'll show you how to do this on your calculator. Although for students who are looking for a little bit more of a challenge in their lives, this needs to be part of your working knowledge. Let's go back to the calculator. And in this case, what we're going to do is go to y equals. Okay, we need to clear this out. Clear all this out. And what we're going to put in is the formula that we got for the equation of the line. And that equation was y equals 1/2 x plus 3. Now to enter it in just as it appeared, we can hit alpha y equals and then enter to get this fraction bar. And we'll put 1 in the numerator and 2 in the denominator. Whoops. And then hit right arrow a couple of times until you're sitting next to the 1/2. Then put an x. And then put plus 3, just like that. Okay, if you want to see what that looks like, it looks exactly like what we drew. And right there is the y-intercept at 3. Okay, and you can kind of count visually. You can say, well, that's negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. But if you couldn't see this graph and you just went to your tables, second graph, what we're looking for, ladies and gentlemen, is not where x equals 0, but where y equals 0. So y equals 0 when x is -6. So it's actually -6 that we're looking for. Let's go back to our answer choices and see where there's some traps laid for you. Okay, they gave you 3 weeks right there. Okay, but they're thinking that, well, the student will identify that y-intercept at 3, and they'll say, oh, it's got to be 3 weeks. Nope. Where the plant is 3 inches tall is at week 0. We want to know where the plant is 0 inches tall. So back in time, 6 weeks back in time. So that's -6. Now we don't have a -6 here because we're not, if you look at the question, it's saying how many weeks prior to the start of the measurement period. The start of the measurement period would have been at week, or at time t equals 0, or week equals 0. How many weeks prior to that did the bean first sprout above the soil line? So in other words, where is the bean 0 inches tall? Well, that's 6 weeks prior to the start of the measurement period. Okay, that's why it's -6. So the answer is 6 weeks. Now I took a lot of time with this problem because I wanted to show all the different ways to solve it, including solving it entirely algebraically by hand. So I want you to know if you're one of those students that's looking ahead, looking up, trying to achieve more, you want to do advanced mathematics, you're trying to become a self-sufficient algebra student, so you can go on and take geometry, algebra 2, pre-calculus, trig, okay, calculus, college algebra, multivariable calculus, differential equation. You want to go on and on and on in mathematics. Please learn how to do this by hand. Do not rely on the calculator. Learn how to do it by hand. When you get into college, you'll see that practicing this skill early will reap dividends for the rest of your academic life and beyond. Okay, so moving on to number 5, the last problem. What is the correlation coefficient R for any data set if all the points reside exactly on a line with a slope m greater than 0? All right. This is a conceptual problem. It's talking about the correlation coefficient, which we're just now starting to talk about. Okay, so the correlation coefficient measures the degree to which the closeness with which points are related to one another with respect to an imaginary line. So let me do something here. So I'm just going to teach this concept really quickly. Okay, you see this mess of points right here? If there is an imaginary line kind of drawn through these points, like this. Okay, let's say that the red line is this imaginary line. Would you say that these points correlate perfectly with that imaginary line, or would you say that these points deviate from the line? Well, the correct response is that they deviate. Okay, and I'll show that with these little dash marks. Okay, these deviate. This is deviating. Here, this is a deviation. Deviation. Okay, there. Right, so they're not all on that red line. So the correlation coefficient between these points and that red line, it can't be 1. because 1 would indicate a perfect positive correlation. Let me show you a graph that has a correlation coefficient of 1. Okay, look at that one right there. Now, if I were to put a straight edge on that and draw a line, a straight line, do you see how all the points are on the red line? So in that case, the deviation from the red line is 0. So the correlation coefficient for this positive sloping line would be 1. And the correlation coefficient is given by the letter R. So R exactly equals 1. Over here with this one we drew first, R would be less than 1. All right, so just a little bit more on the correlation coefficient. If we have data points that are into the negative territory, should probably label these axes. If we have data points that are in the negative territory, like this, okay, down in here. Now this is obviously the curve that fits this data is going to be downward sloping. And there is deviation from the curve or from the imaginary line. Now, a perfect fit on the negative side would be -1. So this would not, it can't be bigger than -1, and it can't be, I should say, it can't be more negative than -1 or more positive than +1. So, you know, R is always going to reside -1 less than or equal to R less than or equal to 1. So for this one, R is going to be greater than -1, but less than 0. So R is going to be between 0 and -1 here for this one. Okay, so a perfectly negative correlation okay, would look like this. Again, where we can fit a line exactly on these points right here. So this would be R equals -1. And then just to finish it all out, okay, here's a graph. We've got data points all over the place. As scattered as you can make them. There is no correlation between this data, and so we kind of draw this flat line here. Okay, when the line is flat like that, or when the data is all scattered around, there's no correlation, so the correlation coefficient equals 0. That's a little bit on the correlation coefficient. So it's saying here, look at the problem. What is the correlation coefficient R for any data set if all the points reside exactly on a line with a slope of m greater than 0? So this graph right here models what's written here. We have all the points residing on a line whose slope is greater than 0, the correlation coefficient is 1. So the answer choice is D. 1. Okay, now that brings us to the end of our journey here with this builder. These were not trivial problems. So this is a builder that I would refer back to on multiple occasions so I could practice these more involved problems. These are good preparation for the STAAR test, and they're also good analytical questions, since a few of them, especially number 4, requires kind of literally out-of-the-box thinking. Okay, you had to think beyond the parameters of your graph. More of a brain teaser. All right, and we'll get more into this as time goes on. Thank you.